All right, so I'm going to give you a quick kind of rundown of what the lab is going to look like for tomorrow. You have an assignment to do with the lab, and that assignment is called a storyboard. So this is something new I kind of picked up, and it did help some of the regular kids remember the procedure for a lab. So what we're going to do is I have outlined in boxes how many steps there are. What you're going to do is illustrate each step of the procedure in these boxes. So step one, you'll illustrate whatever it is you need to do for step one in that particular box. Now, this doesn't have to be a Picasso. It's just a quick drawing so you can reference it during the lab and kind of understand what it was you needed to do and what that would look like. Okay, so all of your drawings will go on this sheet, and to figure out what goes where, you'll have to have the procedure, so that it will be this sheet here, okay? So, things we want to look for, things we want to highlight a little bit and point out in the procedure as far as what do you need to draw, things like that. So up here, this is kind of the general background. So for this lab, what we're going to do is you're going to heat up essentially a metal washer. That's like a little circular disc, basically. You'll heat that up and you're going to record its starting temperature. And then you're going to put that in a calorimeter. And for us, that'll probably be a styrofoam cup. You will set that in there. Since the metal washer is hotter than the water, we're at a warmer temperature than the water typically, or it should be, the water will heat up when you put it in there. So you're going to record all temperatures and changes, and you want to make sure you also record the mass of the washer. So here are the equations, and we did this one on Tuesday. This is the specific heat equation. So Q stood for the heat or energy released or absorbed. CP, that was specific heat. M is the mass of the material. And then the delta T was the change in temperature. And what I'm actually going to do here is I'm going to put in, when we calculated change in temperature, that was the final temp minus the initial temp. So what you have to make sure you do is you're finding the final and initial temperature of water and the sample, and make sure you're recording the mass of water and the sample, and then I'll be giving you some information as far as specific heats. But this is the main equation you're going to be using, so that's very important. Okay, so here is a few other things just to point out. Here you are recording mass of the sample, so there will be some scales out for you to do that. The sample will be a washer. Okay, a washer is not like what you wash your clothes with, but a metal washer looks like this. So I have a circular metal disc, okay, and there's kind of like a hole in the middle there. Okay, that's a washer. Okay, so the next thing you're going to want to do is obtain some string. So here, you're going to tie your washer to the string. Okay, emphasis on tying, and one piece of string should be about this long, roughly 50 centimeters. We're going to kind of guess and check, but roughly it's going to be a little longer than a foot, basically. So here, what we're going to do in step 3 is create a hot water bath, and you're going to have to use this size beaker, 250 milliliters. Okay, so that's something to underline and make sure you label in a picture. And that's going to be half filled with tap water. Emphasis on tap water. It doesn't have to be anything special, just right out of the tap. And half filled, the amount is not real crucial here, okay? Bring the water to a boil on the hot plate. So you'll place the beaker onto the hot plate. So if I am drawing that out, and I'm not an artist again, but here's my hot plate, okay? And I'm setting the beaker on top of that. The beaker is roughly half full of water, okay? And I would kind of label, this is water, this is the hot plate, what size beaker is this, 250. Make sure you label it. Fourth step, we have using the string, carefully lower your metal washer, okay? Emphasis on carefully. We don't want to splash boiling water on anyone. You're going to lower it into this boiling water, okay? You're going to boil it for 5 minutes. This is what heats up the water. So it's called a hot water bath because you're basically giving the washer a bath and the water is hot and it increases the temperature of the water. Don't throw in the entire string. You got to make sure you can pull the washer back out without reaching into the boiling water. We do not want to reach our bare hands into the boiling water. That's not good. So that's why we have the string, okay? So that's step 4. Some things on step 5. In the meantime, what you need to do, this is very, very crucial that you measure exactly or as close as possible to 100 milliliters. The nice thing about water is however many milliliters you measure out, that's the grams of water that you have. And remember, for part of your equation, you're going to have to figure out the mass of the material, okay? So what we've got is we want to make sure that we have really, really close to 100. Okay, if you're not, that's probably going to be a source of error kind of in your equations in your experiment. Now, and again, graduated cylinder, that's the long, tall thing. Don't take out a beaker. A beaker does not measure accurately. So graduated cylinder is like this tall thing with the little plastic base on the bottom. Okay, that's a graduated cylinder. Okay, step 6, record the temperatures of the cool tap water in the coffee cup calorimeter. So step 5 tells you this water you just measured out, you're pouring into the styrofoam calorimeter. You need to record the temperature of that water. That's your initial temperature for the water. And that's stated here and is bolded, so make sure you're paying attention to that. Second step, you're going to take the washer out of the boiling water. But before you do that, you need to measure what temperature that water is exactly at. And that will be your initial temperature of the metal, okay? So these two temperature recordings are very crucial. Make sure when you put the thermometer into your either the coffee cup calorimeter or the beaker, just submerge it enough so the tip is underwater. You don't touch the thermometer to the sides or the bottom or the washer itself. Make sure you're measuring just the water. So just put it in a little bit. All right, step 8, use the string carefully and quickly transfer the heated metal to the coffee cup calorimeter. Now, emphasis on 2 words here, carefully but quickly. If you take the metal washer out and then wait like a minute before you put it in your coffee cup, your styrofoam calorimeter, the metal will have cooled a little bit and you won't get a very good reading on what it was. So as soon as you pull it out, you need to carefully transfer from one to the other. So if this is your coffee cup calorimeter and here is your beaker, okay, I would suggest kind of having these, close. You are transferring this fairly quickly, so you're getting that washer in. Now, do not whip the string across from one beaker to the other. Carefully lift it out and move it over and drop it back in. You don't want to fling anything because we're flinging boiling water at people, and that's bad. That's grounds for suspension and lots of awful things if you do that. Okay, not safe. Step 9, you're going to place the thermometer in the coffee cup calorimeter, okay? Emphasis on placing that in. Make sure, again, it's just the tip that is stuck into the water. In the coffee cup, you're not touching the sides. You're making sure you're just getting the tip of that thermometer in there, okay? Now, once your sample's in there and you have the temperature, you kind of have to wait until the temperature, it'll rise a little bit for the water because this metal washer is much warmer than the water. So you want to make sure you get the final temperature and make sure the thermometer stops moving, okay? Most importantly on this step is what's in bold. It says the temperature that you record here in step 10, that's final temperature for water and the metal, okay? Now, you will do this twice, so you need to make sure you're being very precise and you're not wasting any time, right? You're going to do it twice so you can kind of get a little more data and kind of see how, accurate you can be. Once you are finished, you must tomorrow clean up water, if I have to clean up after you, or if my third hour has to clean up after you, we will not be doing labs. There will be consequences for that. That will not be allowed. If I see things are messy, I will not let you leave until things are clean. So if you don't want to be late for your next class, tardy or absent, you will need to make sure you're being efficient. So step 12 is cleaning. Step 3 is calculate average heat capacity. This one we will kind of work on if we can at the end of the lab if we have time, and then we'll work together to kind of finish that up on Monday. So here's your data table where you want to record everything, and a few things are already in here as far as like stuff you'll need for the equation, like figuring out the change in temperature. Remember, this is final temp minus initial temp, okay, for each of these. And then the specific heat capacity of the metal, that's something we'll kind of calculate together. If you would like to plug things into the equation and work through that, that's more than fine. If you're having trouble, we can go through that together on Monday. But I need to make sure you're using this table to fill things out so we can stay organized. Okay, so you have kind of an outline of the different steps. I've highlighted a few things for you. Go ahead and work on your lab storyboard. These boxes here, you don't need, those are X'd out. Just every step, 1 through 13, needs an illustration, okay? So you kind of have something to reference. This will be turned in as well as the calculations that we'll do together. Those will be turned in with your evaluation. So make sure you have those completed.